All right. All right, so I'm back working on the Ion compiler from Bitwise. Um, it's been a while. It's been a few months since I've been back to this project, so I need to sort of get acquainted with it again. But I did do a little bit of work last night on code generation. So Ion is going to compile one of the targets is C. Probably the only one that I'll implement is a C. Um, compiling from Ion to C. So I'm working on C code generation, specifically on statements. So, um, yeah, so you can see here, I'm just starting uh, to work on statements. I have the simple ones done, continue, break, return, brace block, expression. Then assignment statements, I've done init statements, and if was the last one I've done, so it's time to move on to for loops. So yeah, let's generate for loops. So I have a little test file I'm working in. So let's, you know, use write a function that has for loop in it. The one that's super easy is just like a Fibonacci. It takes, which number in the sequence you want and returns the value. I haven't written any ion code in a while, so it feels a little weird. So we start with one, and then how does this work? It's like that, right? No, but you start at one, right? One, well, it's less than n. Do you less than or equal to? Yeah, you want the nth number. I think we only have post increments. We gotta do it like that. Like I'm used to writing. I like pre. Like, we only have this, and then yeah, you increment your results and then return it. I think that's right, right? Start at one, add every number up to n, return it. So this should fail because we don't have for loops yet. Let's see what happens. So let's see. Make sure we build the latest. And yeah. We fail Cogen 249. That should be this, right? 249, yeah. Because we don't have for loops. Ah, this doesn't like that. Vim really doesn't like when you have a switch statement with cases on the same indentation. Like it really wants this. Um, so for statements, what are we gonna do? First, it might help to look up, oops, like, for statement has an init statement, a condition, a next statement, and then the block. And I can't remember if I implemented optional, like if any of these can be optional, but they should be, so maybe we'll just treat the generation like that. I'll have to look into that. But what are you gonna have, right? We're gonna output like four. It's basically a init condition next and then a block, right? That's basically what you want. Um, honestly, we might be able to, because the semicolons I think are going to be there regardless. Yeah, in C they have to be, so we can just do directly return this string. Which will be like statement, so you recur into this with statement, for statement, init. Then the condition is an expression, so we generate an expression for condition. Then for next, it's just next. And then the block is gen statement block for statement. Whoa, what is happening? Damn, is that really it? That's mega simple. Because we've already, you know, done gen statement block. If you want to look at that, so that's super simple, right? Like all that does is iterate through, so it gives you opening and closing braces for a block, and then iterates through all the statements in the block and calls gen statement block for it, right? This DA printf thing is just my dynamic array, and so it's like a stretchy buffer, and you just use it's a character array, you know, and when you it allows you to like format string print into that buffer, so like a string builder type of thing. And so that calls into gen statement C, which just switches on the kind of statement it is and generates, you know, the C code for that corresponding ion statement. Yeah, so maybe that'll just work. It seems too easy, but we'll see. We compile. And let's see. Something exploded. Let's run it in the debugger. Yeah, we got access violation. We're trying to read something. Dog's barking. So what was that? It's this thing. An assignment statement. Oh, I remember writing this. Yeah, so the problem here is we just have an extra argument that's not getting filled out. That's a copy paste error. In here. Alright, this one has 3 arguments, this one has 2 arguments. What about now? So that runs fine. Hey, there we go. So, also in Ion, all functions are function pointers, so it avoids some of the screwiness of C having to have them separate, so that's why it's written like this, right? So fib is a pointer to a function that takes int, returns int, that's right. You start with the results. We have double semicolons here. I ink? That's not right. Where's that coming from? That seems like it's coming from the print. I remember writing it in the printing for like the S expression dumper, but I don't know why that's showing up here. That's right. Okay, so we're close. So the init expression already outputs a semicolon. Alright, it already puts it here. So I'm asserting that there is one, but you might not have one here, I guess. Alright, maybe we do like init. Is this, but maybe we do for statement init. If there is one, we generate it. Otherwise, we just have semicolon, I guess. Alright, then the expression, suppose. This is the condition. Else empty string. Always have a semi, I guess. Yeah, so if there is one, we generate an expression for it, else it's empty string, always followed by semicolon. Then next, could have just done a place, but whatever. Why did the yeah, what happened here? Gen statement C, isn't that a, so I think like this is actually an assignment statement. So it has no right hand side though, so it should just be this. Hmm. Init condition next. And then this statement block. So that at least fix the semicolon, but I need to figure out what's going on with this next. Compile it. Now we got double semis here. Where we didn't before. Oh. It's just this. Alright, but let's look into this next statement. So, break here. Let's compile. So, init and condition I think are turning out fine. Yes. Yes. For next, what's happening? It's an assignment statement, sure. Let's look at the statement. Statement assign. It has a left, right is null, right? What is the left one? Expert name and the op is... Oh, okay, I see. It's because of stir token kind or whatever it's called. Like, if we look in the Lexer... Or what is it? Token... Here, token kind to string. Ink and deck, we have like this for the S expression dumper, just for readability, but yeah, we don't need that. We can do it like this. Are there any other ones? Name float and integer shouldn't matter because we shouldn't ever see those in C code generation, so I should fix that. Gotta drink the tea. If you wanna succeed in the games industry, gotta drink the tea. Did I compile? It did. Alright, now what do we have? We have 4, int I is 1, I is less than or equal to n, I plus plus. So we have a space in here. That's also probably because of this copy paste. Yep. Alright, so that should be it, right? There we go. Oh, we don't need semis after the last one. Do I even know how to program? I don't understand what's going on. There we go. Fuck. Okay. So now my problem is, we have statements always, outputting semicolons. Maybe we need to move that logic out of individual statements and into maybe like the statement block. First of all, I don't even know if it's legal to have this like, and let's see, if we were to put this here. It's probably fine there. N is undeclared. Missing that before semicolon. Seems like it's not allowed. Yeah, okay, so it's not just aesthetic. Seems to be invalid, at least according to MSVC. Okay, so yeah, it looks like we're gonna have to move semicolon insertion out to the statement block. So you output this and a semicolon for each statement in the block. And then in here, just, oops, remove all of them. So here, yeah. Okay, then we can manually insert them. That wasn't so bad. Alright, are we still working? Yeah, statement blocks don't need semicolons after them. So suppose we're gonna have to say if block statement that I kind is statement block, which I think is what it is, right? It's not a thing. Is it brace block? Yeah, brace block. So if it's not equal to that, are there any other ones that don't need turn, continue, break? This doesn't. If statements don't. For statements don't. But those all have brace blocks in them, right? Well. They do, but yeah, so this says for do while switch. All of these don't need semicolons after them. So I mean, I could just say, you know, just explicitly check every one. I feel like there's maybe a clean way to do this. Right? Like when they're up here, you know, let's just check them all. So we're gonna need to do this. Statement is blocks, statement should I. Statement kind, statement's a pointer, right? Yeah, I think so. So which ones have less? So we have 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. Literally the same. Alright, so we'll do the positive one then. So should we write a helper for this maybe? If statement statement, semicolon, statement. And print a semi. Jesus. Fingers are all over the place. I don't love that name. I don't know. Semicolon follows statement. I mean, I feel like we should put C in there because we've, that's our convention. It's like, gen is kind of the module, then whatever you're doing in there, and then like the backend, or the target, I mean. So, let's put this little helper right here. So bool, gen, semicolon follow statement, takes a statement pointer, and then you just return which ones. Return, continued break, no. No, no, no. Actually, do? I think it does, right? Because you have do, while, thing, semicolon? Yes? So I think do does, while does not. Switch no, assign an expert, okay. So why don't we do this? Statement 9 is equal to that. And then let's replace commas with space ors. And then let's make it look all nice. So return, continue, break, do, assign, and expect. These all need semicolons after them. Does it compile? It does not. Whoops. How about now? So these get semicolons. If does not. For does not. These are all good in here. Okay. That seems good. Alright, we got 4 statements. Let's do do. So for do, we have do, do statement block. And how's that gonna do for, like new lines? I think statement blocks do what? Right here. It says they print this. So in this case it would be this, then it does a new line and an indent, all the statements, then that. So it's gonna end up looking like this, which is what I want, and then while. Okay, so do statement block, while, open, condition, and then semicolon, which happens outside of the caller will take care of that. So yeah. So we're gonna do statement blocks. So statements, do statement. What do we have for do? Oh, I see. So I think do and while have different kinds, but the data in the statement struct in this union, I think they both use while. Like there's no do statement, yeah. So statement, while, statement, block. So gen statement block C, this block, and then gen expr C statement while statement condition. And of course we need a test for that. Let's just throw that in here. So I don't know, do. Oh fuck. How do these go in Ion? I imagine the same way. So do. What do we want to do? I don't know. Just increment I, who fucking cares? Doesn't matter. While I don't know, while this character is equal to B, who fucking knows? What do we get here? Unexpected token and base expression. Oh, do we have character literals? I don't know if we do. Let's not go down that rabbit hole yet. Let's just say why j is equal to pi. Conditions. Wait, that is a bool. Must have type enter bool. Interesting. I don't actually know what it's doing there. Let's hoist this up and investigate that. So let's do a func test do. Actually, I don't remember. I don't think you have to do that in Ion. We could just do this. I don't know. I is 0. Float. Actually, no. J. What are we doing? We'll just do this. Well, yeah, because we want coercion, so let's just do I is 1.0. I plus equal to 69, of course, while it's less than pi. Sure, makes no sense, but whatever. So here what happens, we explode unknown symbol J. Cool, condition must have type. So let's see where that's exploding. Resolve expression condition. So after we resolve the condition, the type is float. The value is 0. So it's in this resolve expression. How many expressions come before it? There's one. We'll just break here. So what's the expression? It's this binary expression where the op is... The op is 60, which I'm assuming is equal to... Left is a name, the right is a float, right? Which is... I... Oh, it could be this. No, but it's conditioned, so it's this, right? Okay, so that makes sense. So this is the right one. If we go into resolve expression, what happens? Resolve expected expression. Do we have an expected type? I don't think we do. Well, we do. It's... Wait. No, it's null. Okay. Extra binary. Alright, left and right. Yeah. So they're both type float. So for a binary expression, they have to have the same type here. That's not exactly... I don't think that's what we're gonna ultimately want for like these comparison. Well, yeah. It's just that after the evaluation you want it to coerce to bool, I guess. What should we do? Let's just follow this out, right? So we get the results. Expert binary. So when we're in here, we don't know it's a condition. Right, that's all fine. That stuff's all fine. Resolve expected. So when we're in here, this is what we get. So I think what we want to do in here is coerce it to enter bool, right? That makes sense to me. So like after we resolve it, we want to say like what does resolved expert have again? As a type, right? So the val is int val. What about for floats? That seems bizarre. I mean, I guess it doesn't matter because you can just interpret it as a float later, but that seems kind of weird, right? So for like this, for this expression, the resolved expression will have a value of type N64. I mean, I guess it's fine. It just seems really weird. It's like, let's kind of keep that in my head that that seems a little weird. But, um, regardless, we'll jump back to where we were. So, resolved expression. So what I'm thinking right now is just like, this thing's helping me out by like making sure that the things that are used in a condition are okay, and I want to make sure we enforce that still as much as possible. So like, for example, what this is saying is like, alright, resolve the expression no matter what it is. Maybe we could check the expression kinds. Like it shouldn't be able to be... Well, maybe test will catch that. What I really want to do ultimately is say this, right? Like, so you have a resolved val. Is it called val or int val? It's just val. Oh, here. Do we just coerce it to 1? Like, that will work, but we lose information about, like, what the expression actually resolved to. So I guess what we want to see is who calls resolved, resolve expert cond. I need to sit up. So in ternary we call it. And while right, we're not doing anything with the result, so it's fine. We're just validating it. Same here. Same here. Here we are though. So the resolved expression. What do we do with that? This is not used. Okay, so in that case, I don't know, something like coerce. Truthy values, i.e. anything that is not 0 becomes 1. So coerce all values to truthy values and force the type to be int. We'll go with that. So now we have this. Do while, yeah. Seems right. Cool. So let's go back to our test. I kind of like having it in the mega func, but it really matters. Okay. Also, we're not preserving white space right now, but I don't think there's going to be a one-to-one. Well, yeah, we're just not going to do it. Okay, we did do. Let's do. I feel like what I'm thinking right here is just typically the functions that we preface with like the module, like gin in this case, are usually more intended for like external use. So if we give it like, we can also mark it static just for, I mean, this is a single translation unit anyway, so everything is basically static. Which we should probably mark all these functions. Like we have a function is typedef to static, or rather defined as static. My understanding is that that can help with compiler. I don't know if it's exactly optimizations, but like it can reason more if it knows that it's all in the same translation unit. It doesn't have to do certain things that would make it visible outside. So there's that, but I'm not gonna deal with that right now. I just am thinking this makes it kind of more clear that it's an internal function. So we're gonna go with that. Okay. So we got do while's gonna be like the same thing, basically. Right? We just have kind of the same shits. We have while this. So while this condition, then the block. So what can we do? I guess we can also check this condition thing. Still don't know if we have character literals. Maybe that could be a thing we implement next, but we say while k, I don't know, if it's an ASCII character, let's say, well, it's less than z. What's higher in ASCII? Lowercase or uppercase? I don't know, it doesn't matter. Oh wait, that's not a character, it's a string. So I don't know, we could dereference it. While the first character in the string is less than z, like, change the character. Sure. And then I suppose maybe we should, I don't know, just test multiple statements. Unexpected token and base expression, this, because I don't think we have character literals. Okay, well, let's see. What is the 122? Can I do this? Since it's not Unix. Type mismatch for left and right side of binary expression. Interesting. Line 43. Which is this? So when you dereference a string, we get a character. Alright, so the question is do we go down this fix rabbit hole right now, or is this we don't. So how is this? I don't know. 65536. Doesn't matter. I'm very unimaginative this test code. Okay, so condition, alright, the following. What was the error we're getting? Gives the error. So what is it? Okay, resolving following statement. Resolving the condition in the following while statement gives the error. Alright. Where K is of type char. Dereferencing a char pointer should give us a char, no? Or maybe it does and this is ent. Ah. Anyway, we'll look into that. So we took a note so we can delete that. We got while statements. Looks like all we got left is switches. So yeah, let's look into that. So what do we have? For switches, you're gonna switch on, you know, this thing. And then what? We don't exactly have a block. We have a bunch of switch cases. Been having some like hand pain lately, programming so much. It's kind of scary. Like you know, don't want to exacerbate the problem because I want to be programming for a very long time into the future. But I think not resting my wrists is helping, so it's trying to keep good posture in that. Anyway, so for switch statements, so switch statements. We have switch cases, which are these things. You do have statement blocks in them though, which is actually great because that means it's going to compile to C in my favorite switch style, which is this right here with the braces. Uh-huh. Alright. So, and, well, what we do need to think about is, in Ion, is there, like, explicit break? I think so. Also not what we need to focus on right now. So we switch on this, and then we have one of these. And then we're gonna... Do we indent? Let's not. Let's not, because I don't like to. So that switches will come out like this. Like, or do we want them like this? You know, let's just do my style. Bug it. So we are going to be building this up quite a bit, so I think what we want to do is have one of these stretchy buffs. So this buff macro is just an annotation. Like, it does nothing. Whatever you put into it, it spits right back out, so it's equivalent to this. It just annotates that this is in fact a stretchy buffer. The reason being is because we're just going to leak this. It's a compiler, right? Like, so it's not a long-running application. It's just going to allocate all the memory and then exit the program and let the operating system clean it up. Great, so we have printf into this string, switch on this condition, opening up a scope. You're gonna have to put some shit back there, but then we're going to indent, increment the indent, and do new line. Does that take anything? Gen new line takes the buff. Okay, so into this string. Alright. Then what? Then we're gonna iterate through. What do we have? We have a statement. Let's highlight. Oh, switch. Switch statement. Num cases. Let's make that clear. So for all those, we're gonna, add the generate all our code for that. Then we're gonna print out or wait, we're not gonna indent. Then we close out the switch. And return the string. Okay, so for we're gonna switch on this expression, which is gen expr c statement switch statement extra. Then for each switch case, what do we have? You have potentially multiple expressions, right? So we need to spit all of those out. First of all, we can check if it's default. Yeah, so if, so let's do this. We're gonna have a switch case. What is this? It's an array of switch case or pointers, switch cases themselves. So, we can have a switch case. Is statements, which statements cases at I. So we have its switch case. Ooh, but this is gonna have a statement block. I don't think it's a huge deal right now. It's kind of a bunch of variables. Should we do that by pointer? Instead of copying this variable? I don't know if that really matters that much. We'll leave it. We can profile. So if a switch case is default, then what are we gonna do? We're gonna output default. Otherwise, we do something else. I think you want the colon too. Otherwise, well, now we have to iterate again. Well, we can do this, right? For the switch case, num expers. Switch case expers at I. Sorry, expers at J. So we're going through all of those. We're going to output case this colon. This is going to be gen expr C. We can just do this directly. I'm gonna put the space because the last one's gonna have, you know, followed by that. It's blocked, so I'll leave that because all the other ones are gonna have a new line because if j is less than switch case num expers -1, then in that case, I suppose we don't even need this. We can output gen new line. What's going on? Do we run out of tunes? I think this is one of those like secret tracks on the end of an album or something. Okay. Put that up. Nah, we'll put it down. Okay, so for all of those, you do case, that, thing. Sorry, colon, space. So we do that for all the switch case expressions. Right? Then you're going to do the block. So I think it's just that. Gen statement block for switch case block. Alright, does that compile? It does. So let's check out this. Can we do a switch on? You know, can you take a guess? That's right, I. We're gonna switch on I. So for these, what should we do for all these? We'll just set J to like, I don't know, random shit. Default, yeah, of course, is gonna be I guess. We want to have some that are multiple, so 1, 2, 4, and 6, 3, 5, and so that, something like that. 1.1, 1.2, 1.69, 3, 5. Does that even... Alright, so what did we get? I'm surprised that worked. So we're switching on I. Ah, so we need a new line here. But otherwise... That looks right. Case 1, yeah. Case 2, 4, 6, that. Damn, I think we got it. We just need new lines after this. The only problem with this approach, it's not a problem at all. It's just aesthetically, like, if you look at my switches, right, the default is like the only one that doesn't have the thing. Because otherwise you end up with this, which looks wrong, right? So the two ways we can solve that is we either assume that the default case is going to be... Okay, another thing to mention is that like the only time these brackets are necessary is if you're like in C, if you're declaring a new variable in here, you need to have a scope for it. And so I don't think it's fair to assume that default won't you know, declare any new variables. So we're gonna put the brackets in, which means I think we're gonna have to just break my style preference and actually indent. Yeah, so we're gonna indent new line after all of these, a new line, and that should fix. Why didn't we new line? Oh, it's after each. Yeah, that, wait, what? That's after the switch. Yeah, we want it here. Yes. And then at the end, we forgot to... So hold on. What happens is on the last one, we do default. We're going to open a parenthesis. We're going to indent. Boom, boom. We're going to clear the indent. Do a parenthesis. That's in this. We generate a new line, which puts us back here. I think what we want to do... Wait. So I think what we want to do is everyone except for the last one, we want to do a new line there. And then on the last one, we want to decrease the gen indent and then do a new line and then that. So this is only if I is less than statements, which statement num cases -1. Okay, that's better, right? Switch on 0, we do that. 1, we do that. 2, 4, and 6, we do this. 3, 5, default. And I think for default, we also want a space. Great. Now we have switch statements. And I think that covers statements. So we basically have C code generation. Fuck yeah. What we need to do is write a bunch of tests. Well, we already have a pretty chunky boy test of we used for like resolving and stuff. Yeah, so what if we just try to compile this file? So, let's see. What's going on in main right now? We're just calling cogen test. So what do we really want to do with that? Right now we have like this separate thing going on, but... Like, I think this was before we had like a file-based thing. We were just manually constructing these, testing, and after that we added this guy. Just trying to think how I want to structure this. Maybe we really could throw this in here too. What's the type in terms? Yeah. After this you should clean up, so like we should agree the global sims and the ordered sims in case any tests get run after that. And then maybe what we want to do is just, you know, file the file you pass in. If it fails, tell us. What do? We can just failed to compile file this. Alright, so what if we just try to compile the test? Holy shit, does it work? Wait. This is not... Ah, we're not doing cogen yet. Yeah, we're just, this is an S expression dumper. Yeah. Alright, so... we basically want to do this now. Alright, where do we call compile file now? Yep. Yep. Here, so this isn't gonna work anymore. There's another one. So the problem is like we want this to just test resolution, not cogen, and we're about to add cogen to compile files, so you don't want to call compile file anymore. So you know, we're just gonna do that. And actually, we should have freed these after anyway. But alright, we're just gonna get rid of that there. We can just do this here in case we were sloppy and didn't initializing any of these. Then in here we need to change. So that was everywhere where we called compile file, right? So for cogen it's fine because we're actually going to do that. Except we're going to move this out into here. Failed to compile cogen test. Shouldn't we do this on standard error? Alright, so then we're going to go through all the ordered symbols and generate code for them. Right now we're just going to print it all out. Seems... we don't know about Gen C yet. Right, cogen needs to come before. Wait a second, but doesn't cogen call compile file? That would resolve. does. How? Wait, what the fuck is going on? I'm confused, real confused. How does this compile? Right? Like, okay. Codegen is included before ion is, right? Codegen calls compile file. Compile file is defined in ion. I don't see anywhere else where it's forward declared. Oh, but because it returns an int, C just assumes that there's, yeah, any function that you don't define sort of implicitly gets the type int because of old C shit. So, yeah, what you really should do is in here just forward declare it. Okay. So yeah, we go through the other symbols, generate code for them. So can we do that for this test now? That was kind of slow at the end, which made it seem like something might have happened. Just run it on test IO. Exception thrown, yeah. Ah, X per compound. Get the declaration for the type here so we can handle named fields. Okay. Well, first of all, we now have a gen type spec C, so we no longer have to be of type name. We can handle all those. So instead of that, we can do gen type spec C on that type. And okay, this must have been before we had the print, buff printf thing. So we want to have a buffer monster. We're gonna leak it. The first thing we want to put in is this. So we put in there what? This. Yes. So that's the type. Then we're gonna go through the args. And we start with the string, so we're just appending to these things, I guess. Uh-huh. Right, then we can append a closing brace. And return the string. Whoa. And then this comment is saying we want to have named fields so that we're not relying on the order. I think that would be nice. Gen type spec C. Right. I think we don't have anything on the inner of that. And okay. We do want to run it under here though. We don't have a type spec. Who called that? We have an expert compound. So what's the expression? Ooh, but the expression now has a type. Right, because yes, we added in the resolution pass, we have now each expression gets its resolved type added to the expression struct. So you have a pointer to the type, the resolved type. So we can use that instead of this type spec. Expert compound type, no. Instead of that, we do, instead of using the type spec, we use the actual resolved type, and then it's just the expert type. Same thing here for cast. So we want to do that next. So we made it, through a bunch of stuff. Did we get compound expressions working? Not sure. Anyway, where did we break? We broke on this init statement. So we don't have one somewhere. We failed on this. So what's the statement? It's this init. Statement, init. So it's the func pointer. Statement, init, expression. There's no expression. So where is func footer? I see. interesting. So what we're saying here is we have an init expression, or an init statement, sorry, that doesn't have an expression. So I don't know how Per Vognsen, you know, the guy who ran Bitwise, he's the one that created this language. I don't know how he's handling, or how he deals with, or how he even defines like init statements. The way I'm defining them is as so, right? The other thing is like, they're basically the same as var, except for they can only be in function scope. But basically, alright, the point being, what you have is a name, and then a colon, and then an optional, I'll use parentheses to mean optional, optional type, and then an optional equals expression, right? But I guess another constraint is like you have to have one or the other. So you can have something like this func pointer, right, is of this type, but you haven't assigned. It's basically declaring a variable and not assigning a value to it yet, right? But you can also have variables without a type because it's inferred from the expression. So like when you have the canonical I equals 0, this type is int, so it's inferred, so you don't have to do this. I don't know if that'll ever bite you in the butt anywhere. Like right now in the code generation I've just said you have to have an init. But come to think of it, like in the for loops, we're already checking like if the init exists, output it, otherwise do an empty string. But if we just have a init do that for init expressions, actually that's not for the, those are different things, sorry, never mind. But points still stands, we gotta figure out if we want to allow this thing here. Right, the easy fix is like this. The other thing is like, okay, well, is this where var statements come in? Because right now I don't have declarations at in function scope. So what you could do then is just say, all right, well, this is a var func point, like just this. Like you have to say var in order to say, all right, this is a new symbol, basically. Because honestly, it doesn't make much sense to even have this thing. Besides making the parsing way simpler. But like, so at the statement level, you could just have this. Like, what I'm thinking is like the var is kind of, you don't need it at all. Like, does it really simplify the parsing that much? Like, okay, you see var, now you know this is like a var declaration, but like very easily you could just say, all right, just look ahead. Like if the next thing is that, like you always have the colon. Let's look into that. Like, think about removing var keyword. Could just look ahead to see if the next token is colon to tell if it is a var decal. We'll think about that, but for now, how do we want to handle these? Excuse me. Like, I definitely want to allow in a function scope to be able to declare a variable without defining it. That's definitely true. What I'm not sure about is if the way to do that is through a var decal or an init statement. For now, because we don't have declarations at function scope, we'll just stick with init. Yeah. So let's see. Suppose we don't. Well, the other thing is that makes this super simple. Okay, so what are we gonna have? So we start with that. Nah, let's do. This one. If we have one of these, then we output equals that. And then no matter what, we output it. Actually, we don't do the semicolon, do we? No. And then we return the string. What happens if we hit gen expert? Yeah, reassert it. Okay. Access violation. Oh. Oh yeah, fuck. So the other thing is, what complicates this is since we added, you know, the type to the expression, we're using that, like in resolution, when we discover the type of an expression, we assign, like we put a pointer to the type in the expression, so that in code generation, for things like inferred types, we can have the type of the expression somewhere. But now that we're allowing, okay, if it doesn't have an expression, then you're gonna have to use something else. So here's what we're gonna have to do. If there is an init expression, right, then we can just do the easy thing. Otherwise, if it doesn't, we're gonna have to use the type spec. So I suppose we can do that in this one. So we kind of want to go back to the original one where it was like, we just return stir f, where it's this equals this, and you have this thing and that thing. Otherwise, we're gonna build it up, right? So, actually, yeah, this actually does make it kind of better. So, in this case, we just return stirf, where you're gonna generate a type spec with the init and it has a type spec on it, I think, right? Init, yeah. So the init type and the name. That, I think, is what we want. Pass the ion. Why is this still doing the S expression? We're doing both now? That must be main. Yeah. Don't need that anymore. Okay. So I want to check that func pointer thing, right? I hear you're saying func pointer is a pointer to a function that takes an int parameter and returns an int. And you call it with 7. That doesn't make any sense. Probably because we didn't uncomment the assignment yet. So, yeah. Right, so func pointer is a pointer to a function that takes an int argument and returns an int. We assign fib to the function pointer and call it with 7. This is all very interesting. Let's read through this, see if it makes sense, right? So we have vec3. The other thing we need to do is generate all the forward declarations, because we're not doing that yet, because we're going to be using vec3 in places like this where we haven't type def'd it. So we need to do forward declarations. But beyond that, this looks right. Uh-huh. Stuff. There's a lot of parentheses, but it still looks okay. This is looking good. So what we should do is do the forward declaration thing. That way we can just run it through a C compiler. Um, fuck yeah, this is pretty sick. So we need to go back to CodeGen. And I mean, this is going to be part of compile file, right? So before so we're going to parse everything, complete all the symbols. Before we generate code for them, we want to do like gen for declarations. What do we want to pass in? Like global sims. C. I think that's what we want to do. So maybe before we do statements, we can do... is that a void? Or I guess it's a char. It's an array of symbol pointers. Global sims. So yeah, we're gonna need to do for declos. Is that, or you know, why don't we just print it directly? Alright, so we're going to... So global sims, I believe, is a stretchy buffer or global sims. Tag not found. What? C tags. Let's regenerate them. Not found. Alright, well, where is that? In resolve? Global sims. Cause we put it in a fucking macro thing. Yeah, it's a stretchy buff though. So length of global sims. We're gonna go through all the global symbols. And you know, they could be, I guess, types and funcs. I think we just need types and funcs. Because vars and consts should sort themselves out based on the dependency ordering we did. Enums probably though, which is a type. Okay, so if global sims that should we do like sim pointer sims, global sims that if symbol type is sim type or sim type is sim bunk. Well, if the symbol has a declaration, because you know, the built-in primitive types don't have declarations, so we want to skip those. So what do we need to do? We need to generate a declaration for that. So isn't that just gen sim? So we're only gonna hit func and type, but that does the statement block. No, we need gen type. Um, we should just put this up here. Yeah, so let's see. Ugh. So yeah, we just use the type. Primitive types don't have declarations. Skip those. Gen type C. Sim type. Um, so I guess we just want to. New line after everyone. And then we don't want names, I guess? Or we do want names, right? Yeah, we definitely want names, so you need sim name. Okay. I feel like we're gonna end up allocating a lot of memory. Well, no, I think we only start with like yeah. This is not the arena. It's just the stretchy buff. I think we start with sort of relatively small amounts. Although we definitely are still wasting memory, but I just think it doesn't matter. We can check that assumption later. So does that compile? No. I guess we don't know about sim type kind. So yeah, let's read through that again, right? Go through all of the global symbols. If it's a type or func symbol and it has a declaration, meaning it's not a primitive type, then print out a C declaration for that type and a new line. I think we need to have a semicolon in there. Because I don't think gen type C will do that for you. No. Yeah. So let's just see what's gonna happen. We exploded somewhere. Type is null. For what? What's the symbol? Things 0? It's an enum const. Alright, well, it's just, it has to have a decla and a type. I guess. Because the enum consts. Enum const. Wait, how does an enum const not have a type? Its type is int. But it's honestly helpful that it doesn't have... Wait a second. We already said the kind has to be this. What the fuck? Oh, the symbol kind. Yeah, well, why are we doing type kind? It's, if symbol kind... I'm just dumb, that's why. I'm just dumb. Okay. What about now? Now we seem to work. Let's see. So, stuff. That's not right because we didn't do a type def. String as a char pointer, sure. So we have this global var. Type def string to char pointer. Wait, what I want to see is this string. What is that about? That's a type. I guess. So that one's borked. We gotta do type def struct for those. But the functions look fine. Type def is fucked up there. Alright, so we're gonna do those. We're gonna say if it's a function, then sure, we just do what we were doing. Else, if it's a type, what do we do? Well, what do we have in sim type, right? Sim type. Well, the declaration kinds that are in there could be an enum, struct, a union. It's not going to be a func. So it could be type def, struct, union, enum, I think. Alright, so if sim decl kind is equal to decl type def, well, we can do one thing, which is going to be well, I guess we can kind of skip those. Like, I'm not sure what we want to do, because they're going to be handled in order by the ordering anyway, so it's not necessary that we put them all at top. I mean, granted, maybe putting everything at the top, I mean, this is just a preliminary thing anyway, so I think it doesn't matter, so we can kind of just skip those. Type, yeah. So if it's not a type def, then we do the type thing that we just did, right? Not because it has to be different for each one. So if it's struct, type def struct, space, Else if it's union. I feel like, why don't we just do it inline, honestly? Sim name. Struct, union, enum. Enum struct union. Type test already handled, so that's it. About that. Alright, let's see what's going on. So we have type def, union stuff, type def struct vector back to. Then all our functions. You have a vec3 type def. Oh yeah, so that's actually still part, okay. Yeah, that's not gonna actually work. Cause now this happens before this. So let's do all the types first. I think what we want to do is first do all the types, then do all the functions. Yeah. Alright, forward declare types, forward declare functions. So we're not doing that. It's just if it's type. Struct, union, and enum. I suppose there could be a type def before that, so we actually do need the type defs. This gets a little hairy, right? Because, alright, so if we go ahead and do the type defs here, then you have to skip it next time, because you can't do both. Which I'm not really sure how to do. I mean, we could remove it from the global symbols list. Basically, if we skip it now, but do function, well, I don't think we need to do functions because ordering is already handled. Yeah, so really all we should need is type defing the like struct unit enum types. Let's start with that and see where we get. Struct unit and enum. Right, so if we run this, what do we get, right? So you have stuff, which is a union, you have vec2, vec3 structs, and you have the thing enum. Right, well here's what a vec3 actually is. We typed up the string, this is what the stuff is. Alright, so I guess my question then is, alright, if we put that in test C, and then we try to compile, what do we get? Vec3 followed by char is illegal. What? Test C line 11. What? Vec3 followed by char? Oh, these have to actually have semicolons after them. Jinsim. Decal var, decal type def, struct and unions at the end need these enums too. Wait, what happened? Gen sim. Decal struct. And union. We're putting a semicolon after, right? What's going on? Thing? I'm confused. Ah, yeah. It's a pending, because I'm an idiot. Yep. Okay. What we can do here is... Alright, 24. Expected that to follow fib. Wait, you're telling me I can't write a function pointer like this? Interesting, so it doesn't like the function pointer. Interesting. I thought, okay, so let's think about this. C has the whole declaration follows usage thing. Right. So if I'm gonna have like maybe we do have to go the stupid fucking route of so all ion functions are function pointers, so we might have to do like you know, we're gonna have to do this. This declares that fib is a pointer to a function that takes these parameters and returns an int. And then later, is there a way to like just define a function pointer in C with a body? Define a function pointer with body. C function pointer syntax. So you declare and define a function pointer. Let's go to Google. See, define a function pointer with a body. Like all this stuff, I know it's just gonna, I mean, what you want is like, you know, you're gonna have to define this regularly. And then, you know, like this is the declaration of a function pointer, this is the definition of the function, and then you're gonna have to say like fib is fib. Like, okay, you can do that, but that seems like a bunch of bullshit work when you just say like, I want to have a function pointer. The points to this fucking thing. Alright, what if we did, I mean, crazy thoughts here. Can you do that? 4. You don't like that, right? Yeah. Alright, so it's looking like in C, it's basically just illegal to... You can't have a function pointer. You cannot declare a function pointer and define it. Because fundamentally they're different things. In C. So what I think I'm gonna have to do is, you know, forward declare all the function pointers up here, and then for all the functions, I'm going to have to what about is there, you know, I don't have the vocabulary to describe what I'm trying to ask. Like, can you assign like a function literal to a pointer? Like, what I'd like to know is, like, could we, if we have, like, alright, fib is a function pointer, can I say it's, like, some function? Like, this 100% will not work. Just making up. Just making up shit. Like, I feel like I have a way forward that I could solve this. It just seems super fucking stupid, and I don't want to do that. Like, what I can do is do forward declarations of all the function pointers up top, like this. That's fine. Then, when you're going through and generating symbols, if it's a function, like if the symbol declaration is funcdecal, then Hmm. What about? See, we're gonna have problems in cases like this right here. Well, not this case. Hmm. I'm tempted to just remove the function pointer stuff on all the functions. And then, see what areas that causes me grief later when testing. But I feel like the whole point about having all functions in ion be function pointers. Well, it was so that you avoid the issues of C having the distinction between the two, but where does this distinction matter? Well, it matters if you're trying to like reassign the pointer to something else, which is just dumb. Just don't do that for like a regular function. Because like this is all fine if you have like at in at the statement level, if you define some function pointer and then assign, some function that's already been declared to it, that's all fine. That doesn't cause any problems. Seems like the only advantage you get, at least that I'm seeing right now, of having the functions be function pointers all the time would be I'm failing to see it, honestly. I mean, what we could do is go check out like Pear's implementation and see what he does. I'm tempted to do that, but like I kind of want to think about it for a little bit. I'm just failing to see now like why it's useful, at least in the C code generation, to make them all function pointers. I mean, I guess we can just disregard it and see where it blows up. I'm just like cautious because Pear very specifically wanted them all to be function pointers in Ion, and he's way smarter than me, so there's got to be good reasons for that. I mean, okay, let's go for like a decal func. So you do the return type, then we do this, but if we just don't make it a function pointer, then we're all good. Array. Initialization requires a brace initializer list. So for array, I see. So here what we need is, this is a compound literal, but that seems wrong. Although, why can't you do that? Could I just have an array of 5 ints? Oh, right. So for this specifically, you can't do You can't reassign an array to a different array, can you? How's that? Yeah. Left operand must be an L value. That's, I guess, not an L value. Clearly the right way to do that is this. Alright. But what's going on there? Array? What? Oh yeah, it's test. Array of type. This is that. So this is codegen for a init statement. Right? Where the expression is a compound literal, I guess. Is there a way to initialize an array after you've... Like, can I do this and then say that? I don't think so. Error. Syntax error. Yeah, that you can't do. And you're telling me I can't do this? So this is just fundamentally not, doesn't translate directly to C. Seems like we're gonna have to check like if it's an array type when we do the init. So when we do this gen expr, it's going to be an expr compound, I guess? Or is it... see what it is. Can we just do this? Gen expr. Sorry, expr com. Is it this? So the expr kind is expr compound. The type is array. Interesting. So here, if it's an array, then we just don't include that, right? Oh man, my hands. If expert type kind is equal to type array, right? Or rather, if it's not equal to that, well then we can put the type. Man, my hands are really fucking me up. It's not good. Array redefinition, multiple initialization. Array, yeah, that's fine because we did it twice. But I think it's actually okay. Entry point must be defined. Thick, so I think we are compiling, we just don't have a main function. Right? We can just do func main, which takes a you know, argc and argv, which is a char pointer, returns int. I don't know, says fib result is fib 7th Fibonacci number. We just return fib result. No, we don't want that. We want that. We compile it. It fucking compiles. We run test exe. Maybe we just exploded. What's the... How do you see the return? Isn't that like, I don't know, it was something like echo that. I don't know. Print last exit code. You can use error level environment mode while the last code was returned. Error level 22? What's the 7th Fibonacci number? Yeah, I'm just being retarded because I'm tired, so fuck this Fibonacci function, that's all fine. Like, the cool thing is we have a Ion compiler that can now generate C code, and that's pretty fucking cool. Yeah. Right. So I think my first thing was pretty close. I don't want to fucking deal with this stupid Fibonacci function right now. What we can do is just say, obviously return 69. Then, do this, compile it. Ooh, we're not actually. Um, Interesting. Hmm. So what's up with that? Well, we can just take it up. Alright, we say, alright, we return 69 from, so we called main, we move it into EBX, and now what's in there? Can we look at registers? Where's registers? Registers. So in BX, we now have 45, which is 69. Yes. So yeah, we did actually get 69 from calling main. What's weird then, this whole error level thing must just be wrong. Maybe all of this is fine, I just don't understand error level. Like, Windows command is always fucking insane. Error level, that's what it says. Echo error level, that's what everyone says. So, that's interesting. We just run that, we echo the error level. This time it's 69? What the fuck? Oh, I don't think I ran it here. I just compiled? Is that my problem? Yeah, I'm just really being dumb right now. We're fine, yeah. Alright, well, there we go. I apologize for the end of this being me just stumbling over myself, but it's pretty sweet that we now have code generation working enough that we can, compile this this test ion file. And I mean, we can walk through this a little bit and see what's in there, right? So some of the cool things going on is that we have some order independent declaration stuff happening. So let's try to see some of that. Like, let's see. This thing is defined down here. Do we use that anywhere? No. Well, we have this, right? So you have this vec3 dot product that takes in these vec3 parameters, which you don't know what are yet because it's not defined till here. I mean, we can even exacerbate this by putting like all of the definitions at the bottom. Right. So, when you use this vec3, here our compiler will reorder that so that this comes beforehand, so that the C version has a correct ordering in order to output C code with. Um, what's going on in here, right? Like you have some uh, just initialization, you got loops, control flow, you know, a bunch of different binary operations. This one has a precedence thing going on. Gotta make sure the precedence is right. How does the C output look for this mod operation? Right, well we're just super careful, so like all of these we just mega parenthesize so that there's never a question of precedence. You know, we got this, which is actually a binary operation as well. What else? Ternaries. We have compound literals. This is one we just worked on where we have like, it's a compound literal but an array. Which one thing we'll have to see is, I think in ion it would be okay to say like something like that, but that's not going to translate well to C. So maybe it's not legal. I'll have to think about that. Yeah, I mean, you can take a look at what's in here, some of the stuff that's in here. And we're generating this C code from it. Whoops, sorry. I was like, that does not look right. Yeah, I need to take a break. My brain is really fried. So, you know, we're gonna forward declare all of these type definitions. Then all of the ordering stuff comes into play. So like before, this vec3 was near the bottom. You can see that it's been hoisted to the top. Particularly because it's about to be used by this guy. Well, first it's used by this guy, that's why it's so high. But yeah. I suppose what we should do too is maybe call all these functions to make sure that they are, like, show that they're working. So I don't know, we can call test one. We already called fib, even though apparently I'm a fucking retard and can't write that function. We can call vec3 dot product. So what should we do? We can make a vec3 a. Actually, no, we want to write this in the ion code. Yeah, so let's see. A. Let's say like 2, 4. B is 1, 3. And then C is vec3 dot AB. The other thing we need to try out is annotating the C code with line numbers so that we can step through the ion code. I saw Per do that in one of his videos. That'd be really cool to do, so we can debug the ion code instead of having to use the C code. But okay, we're calling vec3 dot. What other functions do we have in here? Test1, do we call that? We can just call test1. We have vec3 dot. We have fib. And then may. Idiot is been going to 69. Let's make sure. That in test C. Can't open it because we're. Exception thrown. Wait, what is this double mod thingy? Huh? How did that happen? Count mod 2 is equal to 0. Whoa, what happened there? I feel like that wasn't there before. What? Okay, so let's see. Sorry, let's check this. Okay, yeah, something's happening here with this. So what is that? It's Gen expert. Token kinda stir. Equal mod equal. Alright, token mod is just in the ASCII, so that's gonna be fine. It's bizarre. Well, let's see what we can do about that. So where do we want to look? Is it in the code gen? Is it parsing it wrong? I want to say... Well, we can check in the parsing, I guess. Let's see. We can check all the binaries. Test on, right? So the expert... God damn it, but the ops are gonna be fucked. Well, we can look at the left and right. Ops 60. Is it decimal 60? What mode are we in? This is decimal mode. Decimal 60 is less than, which means we want to continue to the next one, which is 43. which is plus. Alright, what is mod? Percent is 37. So we're just looking for 37. Right here. So the expression is binary. We're on line 21, right? Yep, that's right. Um, left, right, up. Left is count. Right is 2. Count mod 2. Which is right. So we return that, which would have been the left, right? And so now what we have is this expr that's a binary whose op is token equal equal. Kind of confused. So how are we fucking up there? Yeah, okay. So I'm trying to construct a simpler test case so that I can look into this more easily. So if we do you see we definitely are getting that, so you know, let's step through it. Alright, so we get the first binary where the expression is expression binary. The operation is token equal equal. The left is a binary. So it just looks like this is right? So your expert binary op is token equal equal. So I'm going to skip that one. I want to go into token kind string. So you put the equal equal in there. The string is definitely equal equal. This is weird. Um, yeah, can I just do this? So I don't think I need that anymore. So op is equal equal. Now op is mod. Oh my god, I know what it is. I know what it is. It's my shitty token kind string. Right? I have this big ass warning. This returns a pointer to a static buffer, so the contents will change on each call. Right? Now that we have stirf, we should just use that. We could just allocate. Or, you know, for now, we can just do this. That's a dumb one. That's a dumb one. Well, no, that's still gonna fucking break. So we can just allocate it right now. That'll do a copy. Okay. That's dumb. That's dumb. Mod 2 is equal to 0. Okay, so now if we do test ion, we put that in test C. Um, we run test. Can we run remedy? Where's remedy with... God, this is the worst fucking piece of shit. I can't even close it. God damn it. Wait, did we... God damn it. Alright, we put it out to test C. We didn't compile it because we're being dumb. We're making dumb mistakes. We compile it. Now we run it. It halts with exit code 69. If we step through it, what do we have? Test 1. So is this right? The dot product. What's the answer? 14. So what would that be? It'd be 2 times 1 is 2 plus 12. Yeah. And then my idiot value, because I'm dumb. Alright, it fucking worked. Alright, so we're gonna call that success. So now finally we have compiled that ion file into C. We can compile that to machine code and run that. So we have C code generation. It's definitely buggy and shitty and not finished, but it's pretty fucking cool. I'm pretty stoked about that. Alright, I think I'm gonna hit